Hi, so we are in section 2.6a, and in this video, we are going to discuss measures of central tendency. Now, that's a fancy way of saying something you already know, because most people have heard of mean, and then maybe you've heard of median and mode. Mean, median, and mode are the measures of central tendency. So those are the three things we're going to cover in this section. And I just want to emphasize the name of the section a lot because people find the measures of central tendency and then they get worried because they don't know what that is. But really, I think this is going to be a short video because I think that most people know what most of these words mean. Actually, I lied. It's not going to be short. It's going to be informative in that we're going to be using the calculator for the first time and we're going to get a lot of that stuff out of the way. So that might take a little time. Okay, so here we have 2.6a. using measures of central tendency. So as I said, two main measures of the center of a data set are mean and median. And mean, another word for that is average. And so mean is the most common measure of center. In fact, you use the word average in just daily speak. Median, not as much, and nobody says mean when they mean average, but it means the same thing. And so the center that we're talking about, using for the central tendency, it's just a way of describing what the middle is. And sometimes that means the exact middle, which is the median. Sometimes we're going to average it out. There's going to be other things that come into play. By the end of the video, you're going to know the scenarios for which one is better to use. So let's just start off with the mean. So starting here with the mean, you add up all the data values and then divide by the sum of the total numbers of the data set. And so even though there's a better way to do this, I want to show you a fun fraction thing on the calculator. And so what I'm going to do here is start off with this calculator. Oops, I'm going to stop sharing so it can. I'm going to do this first example. I'm just going to stop sharing so that the screen is much bigger. Okay, so we have here on the calculator, well, we don't have anything, but what I'd said was we're going to add up all the numbers and divide by the total number of values. And in other words, we're just going to make a giant fraction. And this is my favorite because I love this fraction button. You see over here it says n over d. And so when I push that, a fraction appears. And so I can just type all the numbers from my list. Again, these are all from the notes. You just can't see them because I can't show you both very well. But we have 1 plus 4 plus 5 plus 5 plus 5 plus 6 plus 8 plus 9 plus 9 plus 13. And you'll notice the numbers are starting to go off the screen. So it's certainly not going to be the fastest way to do it. It's just, again, I wanted to show you this cool function where we can type in fractions and just do everything all at once. And so counting, I have 2, 4, 6, 8, 10 numbers in my data set. So I'm going to use this toggle button. It's like a little joystick to go down. And now I'm in the denominator, so I'm dividing by 10. I don't need to know the sum of all the numbers, so there's no sense in spending time adding it up separately. Put it in the fraction, divide by 10, and I get 13 halves as the answer. Now that's not super helpful because usually we don't talk in improper fractions. Usually we talk in decimals, but there's this great button down here at the bottom, right above the enter, and it has these two arrows. And I call it the wiggle wiggle button because we can wiggle back and forth between fractions and decimals. So I have a fraction and I'm not doing anything new. I'm just right here at my fraction and I hit the wiggle button and you'll notice the double arrow pops up here and it tells me that 13 halves as a decimal is 6.5. And then I could just keep doing that. I could just hit the button all day long and it'll go back and forth between fractions and decimals. Now, if you have a graphing calculator, I'm going to see if mine has this. I don't use this very often. If you have the fraction button, it'll be this F1 function right above the y equals. Since it's green, I'm going to use the alpha button, the green button. So I hit alpha F1. Okay, mine does have it. And so you'll notice all of these features right here. The first one is just a regular old fraction. The second one would be a mixed number. The third one is to change a regular fraction into a mixed number, and the bottom one is to change from a fraction to a decimal. Again, I don't use these features too often on the graphing calculator, but I could do the same thing I just did by, again, hitting alpha and then F1. I hit enter, and it gives me that same fraction. I'm not going to do the whole problem again because we already know the answer, but again, you could just enter in, I guess it'll take me like 5 seconds to type it in. I'll just type it in. 8, 9, 9, 13. This one's a little easier to see all the numbers that we've typed, so it's easier to see if you made a mistake. Divide by 10, and again, it gives you that 13 over 2. It's a little less convenient to switch back and forth, so honestly, I would probably just type 13 divided by 2 if I wanted to know what that was as a decimal. However, you can do it. You just hit the alpha F1 button again, and we'll go down to that bottom. You'll notice it has that same little wiggle going on right here. It's just F fraction wiggles to a decimal. And there we go, 6.5. Okay, so now we got our answer is 6.5. I'm going to come back over to my notes and write that down because I have talked about this problem way too much. And like I said, oops, I have this whole dual monitor thing. Let me go back to sharing. So if I'm ever looking up, it's because I'm looking at my other monitor. So like I said at the beginning, it's going to be a little more than just your basic mean, median, and mode because we are going to be using the calculator. Okay, 6.5. And I'm just going to make a little note that says calculator because some of you followed along. Some of you followed along on your cell phone, and both of those are not going to be great ways to move in the future because what we're going to be doing starting on number 2, you can't do on your cell phone. And so I just want to put a little asterisk by there just so you know later on when you're looking through your notes, you're like, okay, this is where I need to start going back over the calculator functions. Okay, so here we have, when using the mean to measure our center, we need to distinguish between the sample mean and the population mean. And right now, it's just introducing us to these 2 new symbols. And so this first symbol, the sample mean, the way you say it is how it's what it looks like, X bar. We're going to say these a lot. We're going to use these a lot. So it's an X with a line over the top, and the way we read it is X bar. The population mean is mu. It's Greek letter MU, pronounced mu, and it kind of looks like a cursive U with like a little front tail looking thing. So it's like this. That's a mu. And they're wrong. We don't really need to distinguish between the two today, but you do need to know the symbols, and this will be more important. The difference between the two will be more important as we move throughout this course, just maybe not throughout this video. So as it sounds, the sample mean is the average of the sample, and the population mean is the average of the population. Okay, so now we have Susan, and it says she's randomly selecting a sample of plants to determine the average height of the total 35 plants. Okay, and it gives us our list, and she measured the heights of 12 randomly selected plants. So this right here is going to be, that's weird spacing. I don't know why I centered it. This answer, that's not the answer, but what we're finding is X bar. And the reason that's what we're finding, well, it says sample mean right there, but also we have 12 randomly selected plants out of a total of 35. So anything less than the total is the sample. Remember, all is the population. Any subset of that is the sample. Okay, so how are we going to do this? Well, we add them all up and divide by 12 because there's 12 plants. However, that sounds terrible. Look at all those decimals. Nobody wants to be typing that in. And so there must be a quicker way. You are 100% correct. In fact, this is the video to save for whenever you get lost for future videos, because this is like the whole like first day of the rest of your life thing with the calculator. So what I'm going to do is I'm going to type all these numbers in my calculator. Just going to do a little switcheroo here real quick to make sure we are on the right view. And what we have here, what I want to do is I want to type all these numbers into a list because there's a lot of functions on here and the way we start them is with a list. And so we're going to get, my calculator turned on. We're going to get to the list by pushing data right here, DATA. I don't know why I read that to you. It's because it's backwards on my screen, so I just wanted to make sure you could see it, but I forgot you could see it fine. Okay, so I'm going to type in my list from the notes from number 2, starting with 1.0. And then I type it in, and then I want to make this whole list. So you can see at the top it says L1. I want this whole list to have all the numbers. So 1.0, it just defaults to 1. That's fine. It doesn't really need the 0.0. The 1.4 will stay 1.4. And then we have 1.8, 2.0, 2.5, 3.5, 4.3, 4.5, 4.8, 5.0, 5.3, and 6.0. And you'll notice this last entry, it says L1, that's the list 1, 12, that's the 12th entry. So I entered in 12 things. All right, I want to kind of just hit both of these calculators at once. So just bear with me. If you are over here on a graphing calculator, you're going to not hit list, even though we're doing a list, you're going to hit stat, and then you're going to edit, which is where it is. So you just hit enter. And here we have L1. So we're going to just quickly type all those in, just like we did in the other one. 2.5, 3.5, 4.3. Hopefully you are able to fast forward the part that is not necessary to you, or you could use this time because I'm going kind of fast. Maybe you take a little longer. But just like last time, it says list 1, entry 12. And that is my last one, which is a 6. Okay, so on both calculators, whichever one you're using, I could do them both at the same time. Look at me. Ooh, fancy. Okay, whichever one you're using, we've entered everything in. Okay, so what we want to do is we want to find the mean. And so from here, I want to get out of this list. So I'm going to quit. I'm going to hit, and now that I've gone back to my main menu, I want to hit stat right there. And since it's green, I'm going to hit the green button. Green stat. We are going to be using one variable stats until nearly the end of this course. So almost every time in this whole class, certainly for the next few months, we're going to just use number one variable stats. Now, double check that your screen looks like this. It might say something different, but what it's saying is all of our data is in list 1 and there's no frequency. Just make sure that says 1. We will go into the next problem. I'll explain what that means, but right now it should just say 1. Then you hit calculate and we can see right here what the mean is. And the nice thing about me doing this twice is if I made a typo, I can't hear you yelling at me if I made a typo, but if I made a typo, I'll be able to see if these answers are different. Okay, calculator 2. This time we want to hit stat again, but we want to, You always need, no matter which calculator, you always need to go back to the main menu, to the beginning. So now that we're here, we're going to hit stat. And this time, last time we edited, this time we are calculating. So we're going to calculate, and now everything else will be the same. It's the one variable stats, list 1. For these people, you could just make sure that's blank. It doesn't need to say anything. And then we're going to calculate. And voila, X bar 3.508, 3.508. Perfect. We have the same answer for both. Now it does say to round to the nearest 10th. So we have 3.5 as our, my pen, 3.5 as our mean. Oops, why isn't this work? What? Okay, my pen, there we go. I don't know why it stopped working for a minute. 3.5 would be the average height of the plants. Technically, this is in inches because it says the height is in inches. Okay, so you're going to notice that everything, what am I doing? I'm not sharing my screen. I'm just looking at my face. All right, thank you for your patience. I have not made a video with this document camera before. And trust me, no matter how bad this seems, it's better than the way I used to do calculator videos. So trust, it's improved. Okay, anyways, 3.5 inches. I said it out loud, but now you can see where I wrote it. Yes, that was a little time consuming. It might be a little easier to just enter everything in, add it up, and divide. But as we go through this chapter, we're going to use that list for everything. It is so fabulous, that list. And anyone that was not quite believing me when I was talking about calculators earlier and you're trying to use that one I don't like, you're already like, I can't do that on my calculator. And that's why I don't like it. Okay, frequency table. We have done frequency tables before in the last video. So we know what this means. We know that this means a data entry of 2 with a frequency of 3 means there's 3 2s. And then there's 2 4s. And then there's 2 5s. And then there's 1 8. And sure, if you write out that list, you can absolutely find the mean any of the ways we've talked about. However, this problem was kind of like nice, I guess you could say, in terms of how short it was. If we had a frequency table with 50 values, which could easily come up in a problem, I think we saw one in the last video with like 70 values. If that happens, I'm not making that. I'm not writing that all out. I'm not even typing that all in my calculator. Goodness gracious, 70 things. No, thank you. Okay, so what I want to do is I want to type in this data into the calculator, but also the frequency. And the way I'm going to do that is exactly the same, except not except, in addition to. So this is my L1. My list 1 is everything in data. And then my list 2 is everything in the frequency. So in your calculator, you're going to have 4 numbers in the first column and 4 numbers in the second column. And we're going to use that frequency table to find the mean. So here we go. I am switching back to my calculator. And here are my 2 calculators. I'm going to go back. Oh, this guy fell asleep. That's what happened. I'm going to go back to my list. And I don't even have to quit. I could just go straight to data where I left off. And I'm back at my lists. Now, the problem is, it's not really a problem, but the pain is I have 12 things in there and I could hit delete 12 times. Or if I just hit data again, and you're going to do this accidentally, you're going to be here and you're going to hit it too many times and you're going to end up at this accidentally. So if you're accidentally here, just hit data again to get back. But I want to be here now. I want to clear everything in list 1. So I just hit the number 1 and everything is cleared. And now I'm going to type in 2, 4, 5, 8 into list 1. And then I'm going to hit over. I toggle over with my little joystick here. And I'm going to type in 3, 2, 2, 1. And I know you can't see what I'm typing. I'm just hitting the number, then enter. You could also hit down to go to the next one. Either way is fine. But the point is they both have the same numbers in them. I mean, the same number of numbers. They both have 4 values in them. And the 2 goes with the 3, the 4 goes with the 2, and so forth. So now when I get out of here and I go to stat, so I did second quit, and now I'm going to do second stat, still 1 variable stats. But this time I'm going to tell my calculator that the data is in L1, but now the frequency, remember, that's in L2. So I hit enter, and then I'm going to toggle over to L2. The L2 is flashing. I'm going to highlight it by hitting enter. And as soon as I highlight it, then calculate is highlighted, and voila. There is my mean right there of 4. The average is 4. Okay, let's come over here to this calculator. We're going to quit, start fresh. So I hit stat. And once I hit, once I hit stat, I want to clear the list, number 4. So I'm going to hit number 4. And what do I want to clear? I want to clear list 1. I hit the stat button a lot. I want to clear list 1. Oh, no, that's not right. So sorry. Okay. Clear list. I want to clear list one. Let me just start over. Stat, clear list. Now, which list do I want? I go to the list button. It's blue list. I have the name of list one. So now it says clear list one and it's done. Okay. Back to the beginning. I want to edit. Remember in list one, I want data set one or the data, I mean, from that table. Hit over to get to list 2, 3, 2, 2, 1. And now what I'm going to do, just like every calculator, you're going to quit to get out of here. And then I'm going to go back in by hitting stat, calculate, one variable stats. That's the same for everybody. And now I have list one as my list, but this calculator doesn't let me toggle to get the frequency list. So I have to go to list again, just like we did to clear the list. So second blue button list. And I remember that my frequency was in list 2. So I go down to list 2. And now I have the list is in list 1. The frequency is in list 2. Hit down to calculate. And again, I have that the mean is 4 for this problem that we are working on. Okay, hopefully you are making good use of the fast forward and the rewind buttons, because if the calculator doesn't pertain to you, why are you watching it? If I'm talking too fast, rewind it, slow it down, all that good stuff. All right, so this problem, number 3, we had a frequency, not a frequency, we're doing mean. We had a mean of 4. For what? I don't know. It doesn't say, it just says data, and then it says frequency. Okay, who cares? It just 4. Okay, next one, the median. The median is a number that splits the data set in half, where half is smaller and half is larger. So since I have a nice little data set right here, I just want to talk for a minute about the median. To cut it in half, I have the list of numbers in number order, and then I would literally chop it right there, cut it half. So half of the list is smaller than the middle, half of the list is bigger than the middle. That's what they're saying. That's not how I'm going to do it, but I just wanted to give you a visual since we had this list right here. Okay, so what we have here is a list of monthly average temperatures for New York City. What is the median temperature? We could cut it down the middle. That's fine. You might have done this before in a previous math class. The problem is it's not in number order. And it takes time to put things in number order and then follow rules after that. What doesn't take time, what takes less time is using your calculator. So no matter what kind of calculator you have, pause the video and type everything into list 1. That's a 1 right here. Type everything on this list into list 1. I too am going to pause the video. And when I come back, I'm going to have this list in list 1 in both calculators. So don't forget to clear your list. Go back, practice that if you need to. And then after you've cleared the list, type everything in list 1, and then I will show you how to do this. So I will be right back. All right, hopefully you did pause the video and type everything here in list 1. If not, it's your last chance. Pause it, put everything in list 1, because otherwise I'm going to be going fast through the next part because I already typed it into list 1. Okay, so going to my calculator. Going to my calculator. Remember, I have everything already in list 1. And so what I'm going to do here is I'm going to hit stat. So second data gives me stat, one variable stats. And last time, just one example ago, we used our frequency table. And so we need to undo that. This is not a frequency table problem. So I need to go down to this where see the L2 is flashing. I need to go to 1. Frequency of 1 basically means there's no frequency table happening. So this is what you say anytime that you are not doing a frequency table. It's going to be tricky at first because in this section, the homework problems will go back and forth. But after that, we'll probably just have whole sections dedicated to one or the other, so there won't be too much going back and forth. Okay, so I calculate, and I have my one variable stats here. Here's my mean, which we've talked about before. Then there's a whole bunch of other stuff which we haven't talked about. And so what we're looking for here is median, and median is almost at the bottom. So I'm going to hit down, and I'm going to go all the way down to number 9. And I can see it says MED, that stands for median, and the median is 63. Now, just to kind of do that again, if I get this right here, since median is almost to the bottom, I could actually go up and go the other direction. So I can go up, and then there's the median right there, number 9. The median is 63. Okay, this is much faster than trying to put everything in number order and then finding out what the middle is, I think, especially once you get the hang of it. Okay, so again, on this calculator, I've already typed my list 1 in, so I'm going to go to stat. Now I want to calculate my one variable stats, and just like last time, I have my frequency list here. For this calculator, when I go down to it and I don't want it, I use this delete button right next to the little joystick. So I hit delete, and then I go down to calculate, and here we have it. And I don't have to go down quite as far. The median comes up just one little down arrow. So the median is 63. There's a lot of things here, and we've talked about now 2 of them. And by the end of this class, you will know what all of them mean. But it's going to take till chapter 13 to get through this whole list. So let's just do baby steps. We have mean, and now we have median in terms of the functions that we are going to use on here. Now, oops, wrong button. Going back to the worksheet, we have, well, let me just write down that answer and we are done. So there's not much work shown here because there's not much written stuff that we did. But flag this in your notes on the video, whatever you need to, whenever you need to go back and have like an intro to calculator video, this is it, because this is where we talk about the list for the first time, which we will use throughout the whole semester, and some various functions of that list. Okay, last topic or last measure of central tendency, and then we'll talk about which one's best, is the mode. The mode is not something you're going to get from your calculator. I don't know how to do it, if it's even possible, but beyond that, it's so much faster just to do it rather than to type it. So that's why I've never bothered to figure out if there was a way or not. So the mode is another measure of central tendency, or a measure of center of the data, and it's the most frequent. That's what mode means. Mode means most frequent value, and it should say value or values because there could be 2, 3, 4 modes. You've already seen at some point in your math career that math pays no regard to the English language, and so most doesn't mean the 1 most, it could mean the 5 most, as long as they're all the same number. So here we have, given the set of data, what is the mode? What number appears the most? Now notice they're not in number order, but this list is pretty short that we could see that there's 2 2s, but then there's 3 5s, and there's 1 of everything else. So the mode is going to be 5. That's the most. Mode, most. There's the most number of 5s on this list. All right, 6, see how it's like super fast? It's not even worth typing in the calculator. 6 says same thing. What's the mode? So I see that there's 2 1s. There's a 5. There's 2 6s. 7, 8, 4, 12. All right, so there's 2 1s and there's 2 6s. So they tied for the most. So we put both of them down because there's the same number. Notice in the first in example 5, I didn't include the 2 because there wasn't as many 2s as there were 5s. But in the second example, there were just as many 1s as there were 6s, so we include both. All right, mode's done. That doesn't take too long. Okay, so then now that we have the 3 measures of central tendency, We want to know how to pick the best, which one, not how to pick the best, which one's the best to use in a given scenario. And so it says, if the values are close together and there's no outlier. So if they're close together, there's not going to be an outlier. We're going to use the mean. If there's an outlier, then we want to use the median. If there's just like a big number, a small number, and then a bunch of numbers close together, we would use the median because otherwise the outlier would affect the mean. I'm kind of yada-yadaing over that sentence right now. We will get into much more how the outlier affects the mean in, I think, the next video, maybe the one after, something in 2.6. Okay, last but not least, an outlier and several repeated numbers, we're going to use the mode. So that repetition there is going to give us the mode. All right, but basically between the first two choices, so mode is technically a thing, but it's probably not in the calculator because it's not that common. Mostly we use mean and median, and the difference there would be if it has the outlier or not. So that's really what we're focusing on in these problems. So for number 7, it says in the previous week, a liquor store had total sales of, and it gives us the list right there. What is the best measure of central tendency for the data? So we are not calculating this. Even if we did calculate it, what does that answer tell us? Would you really know which one is better just by calculating the answer? We haven't really gotten that deep into it yet. So just using the definitions above, let's see if this has an outlier or not and what's going on after that. So it does have this, you can see it's a 4-digit number among a bunch of 3-digit numbers. So that's an outlier. It's like $1,000 more that week than pretty much any other week. So this has an outlier, but that's it. It doesn't have several repeated numbers. So for this one, we're going to use the median because for the mode, we would need those several repeated numbers in order to use the mode. So we're not going to use the mode. We're just going to use the median. And probably what's going on is this week was like something that makes people drink. I don't know. Maybe that week was the 4th of July, or maybe that week was, some like Super Bowl Sunday or something like that, where like it's increasing just for that one week, but then the other weeks around it are virtually the same. Okay, number 8, we have the number of points scored for the number of, okay, I can't type. The number of points scored in the last 7 games by a high school basketball team is shown below. What should we use as the measure of central tendency? Now this one, I noticed there's repeated numbers, just one pair of 80s, but it doesn't give mode as a choice. It only says mean or median. So going back up here, the difference between mean and median is the outlier. So looking at the numbers, is there an outlier? Is there one number that's like way off? Like there was before, that 1,600 was way bigger than all the others. And I would say no. The score of 83 versus 80, that's just one basket difference. That's not really super low. I mean, that's not really super high. 83 is not super high. And even down here, 51 compared to 59, 51 is not really an outlier. It's not really too far from 59 in terms of a basketball game. It's 7 points, so it's at 2 3-pointers and a free throw. It's not really too many baskets away. Now, if I had like 21 on this list, I would say 21 is an outlier. That was a really bad game for that team, but I don't have 21. So I'm going to say that the mean is better because there does not appear to be an outlier. Now, one last thing about, I think this was, that's the last one. One last thing I want to say about outliers. As of today, I haven't given you a definition other than just to say it's far apart. What does far apart mean? Well, we kind of talked our way in and out of outliers in the last 2 examples. However, we will have an actual mathematical definition of outlier before the test. So when we get to the test, anytime it asks if they're an outlier, you will have a formula to calculate so that you know for sure. Because maybe you're thinking to yourself, like, I don't know anything about basketball. I didn't know if 51 was an outlier or not. That's fine. We're just kind of going on gut feelings right now, but we will have a concrete definition before the test. All right. If you have any questions, send me in a Canvas inbox message. Other than that, I will see you in the next video.